What's up, guys? Welcome to lesson 4.1, the distributive property. Let's do it. So here we have, with these guys, we got number 18, and we've got 14 times 20 minus 4. Now, when we're typically taught order of operations, we usually do what's in the parentheses first, and then we would carry out the multiplication. The distributive property is something that allows us to carry out these arithmetic problems in another way, but still maintain their integrity, still do it the right way. And it comes in handy when we start using different variable equations, quadratic equations, so on and so forth. So it's really good to understand this principle. The distributive property says that, well, we could carry out what's going on in here first, or this guy could jump and multiply these guys first, so long as it hits both of them, and we would still get the right answer. So let's go ahead and carry out that distributive property. So 14 times 20 gives us 280. You can double check the math if you want to actually write out the multiplication, but it's 280. And then 14 jumps to 4. What's 4 times 14? That is 56. So you see what happens. We've got 280 minus 56. And then we go ahead and do that subtraction, and we get 224. Now it's the same thing if we'd have done 20 minus 4, which is 16. And believe it or not, 16 times 14 is 224. Now we come to negative 5 times f minus 5. Again, distribution. We're going to just jump over these parentheses like so. So this becomes negative 5f. And by the way, this is a subtraction of a 5, which is just like a negative 5 plus negative 5. So that negative 5 times another negative 5 makes a positive 25. And finally, we've got 31 times 11. Now they say calculate this mentally. How does this relate to the distributive property? Well, we could do it like this. This is my way that I would do it. I would take 31, and we're multiplying by 11, but that's a little bit trickier than if we were instead to multiply it by 10 and 1, right? By the distributive property, this is the same as simply adding these and then multiplying. Now, this is a lot easier, because if we jump over here and multiply first against the 10, we get 310. 10 times any number just adds on a 0. So we got 310 plus what's 31 times 1? Well, it's just 31. Now we can add these much more easily, and this becomes 341. So that's how you would calculate that mentally. And now let's go on to the word problem. Sarah charges $6.50 per hour to babysit. She babysat for 3 hours on Friday and 5 hours on Sunday. Write two equivalent expressions for her total wages and then find her total wages. So this is 8 hours total. One way we could write this is we could just say 8 times 650. Fine, done, no worries. If we wanted to use the distributive property, we could write it like this: 650 on the outside times 3 hours on Friday and 5 hours on Saturday. Either way, we can solve either one, whatever is easier. They're the exact same. I'll do this one because this looks a little easier to me. 8 times 6 is 48 plus half of 8, which is 4. So 48 plus 4 should give us 52. And we could do the same thing here. We could say 3 times 6 is 18 plus 150 is 1950 plus 3250. 1950 plus 3250 does indeed give us, yes, it will give us the same thing, 52, just thinking about it. But carry it out yourself if you want to make sure. Finally, 52, we've got a 10 times an r minus s distribution. We're going to let it jump over like that. So this becomes 10 times r minus 10 times s, and that's it. These are not like terms. We can't simplify any further. So this is our final answer, and done.